Hello everyone. Today we are going to work on deep learning, hands-on practices. Um, these days, as you know, the artificial intelligence is a little bit more advanced and therefore practical. One of those approaches to um, mine from large data sets, and therefore we can predict the future. The language that we are looking at right now is R. Basically, what you need to do is that you need to first read the data in and put it in a data frame that is a special data type, and normalized the data, which would be making your mining more sense. Normalization that we looked at earlier. And then you have to prepare two data sets, training data sets and test data sets. And the language provides you a function that we can execute a neural network. And finally, if we can test and evaluate the result. On the next slide, I will explain, for example, given data sets, of course, it should be cleaned and normalized. Then we need to split this data into two sets, number of row-wise, maybe 75% for training data sets and 20 or 25%, even 10% for test data. The best data sets that you can practice is if there is a column that can easily to churn. What it means is that it could be a label, okay, label the column. If there are two values, then a true or false type of values. So when you train your neural network based on this type of subset of data, which is training data, then you need to see, hey, this is the goal. This is the target column that we want to achieve. So looking at these data fields, you could think of the features, all different kinds of features of this record and that record and another records. And looking at this, if the records has this kind of features, then it could fall in this label and another label or target or something to churn. So you can train your neural network. And given test data sets, without this churn column, then you can test this if this predict the similarly that you have here, or that we already have here, right? These are the data sets, the same data sets from here. Therefore, we know as training this, and we drop this field and to test only with this small number of records for all the columns, but the churning column. And then we can compare whether each of these records predicted the way that the actual data. There may be some not only 100%, right? So we'll look at that. To do the all coding, functions that you need to understand are listed here. Attach. So given data, if you do attach, then this is very, very handy. Then you will get data frames. Once you have data frame, then you can apply the many useful functions available from data frames. And then you can scale. Scale is something like normalization. You can use this scale, or you can normalize it as you wish, like this. This is a typical normalization, right? You can use this, or you can use this scale function. If you use this normalization definition that you define, then you need to do here apply. Okay, L apply. So that data is applied to the function that you have here, normalizations. So up to this point, then your data is ready to do something that. But splitting data, you have to split, I think, manually. So once you have that, then you can use, you can call neural net. So there is a formula. What that means is that are you going to, which column will be the target, therefore what other columns that you are going to consider for training. And then there's some other functions that you may think of for evaluation and some of the comparison. All right. So what we'll do is we're going to push this aside. And then there is a, let me show to you two different data sets. This is one of the data sets that we may think of, so-called cars. So this is a customer's data, age 28, gender 0 or 1, in this case binary genders, not more than that in this particular example. And the miles of the car, and then debts. This guy has how many debts, and the income of that. I do not know the unit of those income, and then sales price for this particular ages. Another similar CSV files is like this. If you compare these two data sets, no, not this, sorry. There are many data sets available. Let's say, in this case, the dividend information. There are lots of different the columns available. So this is, for example, market capital, and some of this is, excuse me, dividend, and some of the factors. and this is typical the churn column, which tells us whether that is true or false. If there is a dividend, then 1. If there is no dividend, then 0, things like that. So some types of data is like this. So we can simply choose whether there is a dividend or not. Then we can forecast something meaningfully, right? In this case, even if we have a gender, but we cannot, for example, predict. It's not something that these days that it could be transferred, but it's not like that. So if we say sales, what would be the sales price? If this type of records, different type of records, what would be the sales price? There could be another column, target column that we want to predict, right? But the characteristic, if you compare this sales column here and dividend column here, then this dividend column is more applicable to churn than sales, right? Anyway, keep that in mind. We'll look at so this is also very many records. This a lot more records. So let's work on Studio. Okay, here. Okay. Nice. So let's first set working directory having let's say cars path expression, then it is like this up to carrots, and then we need to read, right? And read, and I want to call it my data. So read CSV from where? In under this directory, I want to read cars.csv. So cars.csv. And then, as I said, I want to make it this convert to a data frame type. To do that, we simply do attach my data. Okay. Then we can do scale normalize, right? Normalize the data. What I want to do is that I want to run, see how much I could get. So far there's no problem, right? My data, these are my data, right? From the car, I know now age 28, gender, miles, debt, income, and sales, which is exactly this. But right now it is in data frame. The beauty of data frame here in this case, then if I want to see what is the minimum of my data, that is minimum of I would say what attribute? Income. What is the minimum income? Oh, that is 0. And maximum income, um, 11,970. What is mean values? Then 61, 6,001. So that is possible as far as it is in attached to data frame. Now we want to do normalize. So I would say scale, and then my data. This is a given normalization. So I would say scale SC data. Okay. This is scale data. So we can again try to do that. Then SC data will be now it's all normalized, right? It's not the given data. Meaning that it can be compared with the others, or actually what is the range of the data? What is the current data? It's like a percentile, okay? Not exactly like that, but something like that. And then we can do let's say, or you can, okay, and then training and testing data, test data. How can you make it? So train data, train set can be obtained from, for example, the scaled data, which is normalized data. There I want to get 100 to 150. First 150 rows, that will be the trained data sets, and test data, test set will be the rest. So 151 to 166. Remember that colon means first row to 150 rows, and then comma, and then column. Column wise, we want to take all the columns so far, right? That is what it is. And then we want to include library and neural net. And then neural net, we specify the target is a sales based upon for example age plus debt plus income, and then data is nothing but the training data sets. So train set and hidden the layer would be 2 and 1 What that means is that we have 2 nodes and 1 nodes in the middle. And then linear output equals false. False. And then threshold equals 1.01. That is a neural net. We execute the neural net and we call it nn. Okay. And we can plot nn. Before we plot nn, we can say what is the nn, the result of a neural network. The nn, this is the result of a neural net training. Then it has all different these kinds of the fields available. The one that we want to from here is this resultant matrix. Okay, that is it. So I wanna print this, and then plot this. Okay, that's what I want to do, and see what happens. Oops. Threshold maybe. There is a 2 times of equal sign. All right. So these are the neural network. It's constructed in this way. Remember, I had the age, debt, and income. I have age, debt, income. We have 3 nodes. Input. Given 3 nodes. Internally, the hidden layer, 2 nodes and 1 nodes, and then this is the output nodes, which is sales. Remember that the concept of neural network that I already posted, so you can refer to that. So we build like this, right? So it's very simple code can make this. If you want to make this, for example, 3 and 2, then it'll be different. Oops. If I save this, I want to run this, then it'll be different. Okay, it is drawn here. Remember that here we have hidden nodes 3 and 2 if you compare this, but because we have here 3 and 2, right? So let's stick to 1 and 2 and rerun. So we have that. All right. Now this is, so our neural net is trained. Now we need to test, because we already set aside a few records for test sets, right? So we want to test it. How can you test it? Then we need to, this test set, then we need to drop the target column, right? How can you get that? You need to have a subset function. So that is from test set, and you want to select only the columns age, debt, and income. So apparently there is no sales column included, right? As I said, when we want to test, then we want to have this, right? I want to this is a training set. We already said this is sales is our targets. That's what we had here. Sales is our targets. And then this test sets, we need to drop this sales. And also keep the columns that we had for training sets. We had age, debt, income, so we keep age, debt, and income for this subset. And we call this, we name it, we can call it, I would say temp test. Okay, that's a real test, right? And then we can do compute. How can you do compute? Compute the neural net that we already trained. This is a neural net objects, right? We already trained that. We want to apply temp test to it, and then it'll return the result. Then we call that test result. Okay, we call it test result. And then we can construct as a result of this construct a table, column by column table with the columns, say actual and predict. To do that, we need to have a data frame, and actual equals, what is the actual ones? Actual one is actual one is here, this test set where there is a sales, and then prediction equals test that result, which is this compute, right? Because we apply our trained neural net to the test data sets. In this test data sets, we drop the target columns. And then this is the trained result. In this trained result, then we have net result column. We call that final result. Okay, and let's run it. We don't need to see here. Software out of a bound. Temp test is okay. Error in X subset. Subset, test set, subset that comes from test set. We select age, DPT, and income. So we drop subscript out of bound. Out of bound. Let's see. Head. I want to see head here. Test set. I want to hold this plot. Okay. So we have age, gender, age, oh, DEPT, not DPT. All right, that's typo. So prediction is a test result. Let me see. Test result and okay, net result. This. Test sales operator is invalid for atomic vector. Oh, this is atomic vector. Oops, not here. So let's see. This is atomic vector. That's what it says. So run it. Or test here, that is also atomic vector. Test set. Test set has yeah, all of those. We want to have let's say sales. Test set. Let's say test set equals $sign and sales should be there. Sales. Just simply say we can do test result and test result. Test result has net result. Sales. let's say test set, test set sales. Test set, I would say 1, 2, 3, 4, 5, 6. Test set 6. Test set 6. Test set 6. Test set 6 is okay. So instead of this, we can, another way that we could do is test that and then 6th column only, and then test result. We have the test result. So test result itself is test result. So we don't need to say that. And then we can run. Very good. Then if we see, oops, come back here, result, then you can clearly see this one is actual, this is predicted. It's not really well predicted, right? This is actual, this is predicted. But if you compare, let's say this is, yeah, all, there's not much that we could do for this, right? But if we would do this Python or TensorFlow, then we can manipulate the iteration. So depending upon the number of iteration, this could be improved a lot. Right? Right now it is that much. So yeah, if you can use this for example, other here dividend info. Then you can do DIVIDEND dividend info, and then I'm not sure how many there are. Did they say how many? Yeah, 200. How many total? Yeah, 200. So 170 and 171 to 200. So bottom 4 here, 175, 175. Probably from here that is the test data sets. Above that is training data sets. And then let's try, this is rather than sales dividend, right? We need to say here dividend based upon what? Based upon, say, FCFPS plus earnings growth and DE. You can try more. For example, MCAP. And data is train sets and hidden maybe you could have oh, rather than I made this 1 and 2, which is no good, right? And 3 and 2. And then I can make this plot. Let's see how it goes. Run. dividend the info, dividend info, dividend info dot csv, dot csv, and we can run it. So that is constructed, right? Like this. FCFPC and earning growth, DE, MCAP, and then dividend at the end. And then we had this, and we need to, again here, FCFPS and earning. I think I rather copy all of this. And I want to make this copy, and then I want to have here a plus sign and another plus sign here. No, I think I need to do only comma, because this is concatenate, right? So comma. Concatenate, so these columns only selected from this test data sets, and then compute that, and result is the same. Okay, so a small change from the previous. So let's see what we have. Oh, we got that. And then if you do result, then we clearly see this is a predict, this is actual, and this is predict. Yeah, there's some, it's not really well trained yet, right? In R. So if you see it, Python, then it would be, we can improve this. We can manipulate it at least. All right. So this tutorial gives you how you can set up neural network, and therefore you can train it. The way that you can train here, if you change this a little more, depending upon the number of the columns, this is the target columns. Target column is okay here, but if you use a little less, then it would be maybe better. I'm not sure, right? And also this hidden layer, if we want to make this maybe a little smaller, let's try a little smaller, and then this, so again little bit smaller, and then run this. We do not know yet, but result, then we can see, I think this is much better than the other, right? It's a 9, and this is maybe not necessarily, all right? But anyway, you have, you know how you can build a neural network, how you can predict. The predict is you need to manipulate training data sets and test data sets, for the test data sets, you have to drop the target column, and finally you need to compare the actual target column value and predicted target column values. Okay. All right.